Hello, my name is Dr. Allison Justice, and for this month's Café, we are going over a research report. So this was a project that was done last year between the CRC and SAS. SAS is Sustainable Agro Solutions Group. They are a company out of Spain that have been creating agricultural products, biostimulants, fertilizers for the agricultural community for many, many years. Now, they've done things right and not just jumping into cannabis thinking, well, this works for other plants, it'll work just as well, let's sell it before we test it. Instead, they had us put it to the test. And so for this project, we looked at the effect of their products, their biostimulants, two particularly, in addition to an NPK program, so salt fertilizers, on vegetative growth. Now, we looked at vegetative growth for 10 weeks because we wanted to make sure to give these stimulants time to actually show us results. As if you're an organic grower and you're applying products like this, as you know, it's not just a one and done, it takes time. So we'll get into this today. First off, we should talk about what is a biostimulant. Well, someone has to define that. And in the United States, most things, especially if they're regulated, fertilizers being regulated by the government, it needs a definition. And so the 2022 U.S. Plant Biostimulant Act actually gave a definition for the U.S. to be able to regulate these products properly. So in this definition is a substance, a microorganism, or a mixture thereof that when applied to seeds, plants, rhizosphere, etc., it acts to support the plant's natural processes. By incorporating it, you may have an increase in nutrient availability, uptake use or efficiency, tolerance to stresses, and consequent growth, development, and increase in quantity and yields. So that is the definition. Let's take it a step further. I like to paint out pictures like this to really wrap my head around certain processes. So as a biostimulant, these can be broken down in two ways. So non-biological and biological. Now, biological makes sense. These are different fungi, bacteria, etc. that when applied either release certain chemistries or cause the plant to react and release chemistries that increase yield, growth, etc. Now, again, as you know, if you are an organic grower, it depends, right? It depends on what the other feed is that you're applying. It depends what sort of soil you're using and what sort of nutrient it provides already. It depends on a lot. Some varieties are heavier feeders than others. And so getting this combination, this rhizosphere for this living soil is really what it takes as far as being successful. Now on the non-biological side, we've got, the compost teas, we've got beneficial elements, botanical extracts. So these aren't actually living plants or organisms you're applying, but it's the leaves that potentially have extracts that could be a biostimulant. Lots of seaweed used in our industry, biopolymers, humic substances, etc. All of these cause the plant to do different things. And most of the time, of course, depending on rate and duration, poisons in the dose are all positive things for the plant. Now, digging a little deeper, what do these do? We know what they are. Now, what do they do? There's so many. So keep in mind, this is just a broad idea of what biostimulants can do in general. Water use efficiency, root structure and growth, nutrient use efficiency. So potentially these substances are helping break down the nutrients where they can be absorbed by the plant. Disease tolerance, induced systemic resistance. That's a big one. If you think about regalia that we use, helps with powdery mildew. Well, this is an extract from a plant that goes to then help the induced resistance of plants we apply it to. And stress tolerance. Stress tolerance is a big one. As mentioned before, there are lots of types of biostimulants. There are different combinations and durations and concentrations and methods of application. So SAS has had the time, the R&D, the efforts, the mixtures. They have got this down to working with the crops that they currently work with. So they have an idea of, which biostimulants of the ones they produce should be applied at particular times in the plant cycle in order to be the most beneficial. And so here you can see some of their different products and what they recommend for cannabis based off what they have seen be beneficial in other plants. So we've put 2 to the test based on their recommendations, and I'll introduce those now. In our project, we used 2 different formulas from SAS. We've got Kodasting. Its general makeup is nitrogen, free amino acids, organic matter, and different stimulants. The other was Kodas and Reticular, and it is free amino acids, nitrogen, and phosphorus and potassium. And so as you can see, these are a little bit different formulations of each other, right? Both being free amino acids and then different elemental elements added to the mixture. So different elements, different purposes at different stages in the life cycle. So next we'll show you when we applied these, how, and the recipes behind it. All right, so here's our treatment date. So on 6/3, we stuck the plants, and so this was application of early treatment as a plant in propagation. You can see the application volumes there. We had a weekly application of Kodas and Reticular for 3 weeks in a row. And then when we transplanted to 1 gallons, we began a rotation of Kodasting and Kodas and Reticular every week for 10 weeks. So this was a 10-week project, including propagation. The rates that were used for these products are here in the following. So for Kodas, it was a drench at 18.9 milliliters per gallon. These products do come in a liquid form. And then Kodasting, which was always a foliar, at 4.7 milliliters per gallon. Now here's our general material and method setup. So as you can see, we started with pretty low light and propagation, going to about 400 ppfd later in life. Fertilizers, we intentionally kept it quite low, so just barely any fertilizer there in propagation, but it was set with a starter charge, and then getting up to about 1.8 as the plant matured. Now we wanted to keep it on the lower side because most organic growers are not pushing EC as a conventional grower would, and so those benefits of biostimulants really come through when you're already not absolutely loaded with fertilizer. So we kept it at about a medium stage of 1.8, high humidity and higher temperatures throughout the whole life cycle of this project. At week 3, we wanted to evaluate rooting performance. So these plants were stuck in root riot, and at week 3, we looked at the treatment groups as well as the control. So treatment groups are there on the left and control on the right, and even though it is harder to see in these pictures, there's not much difference. They're all fairly well rooted and ready to be transplanted. So looking a little closer at the data, we did an actual score rating system with 0 meaning 0 roots and a 5 meaning completely rooted, ready to transplant. You'll see the breakdown in means here. And so looking at our p-value and students' t-test, there was no significant difference between. So no positives, but also no negatives from using this product. But as we said before, biostimulants many times need time in order to show the benefits they're giving. So let's keep going through this project and see what happens. At 6 weeks after stick, it was time to transplant into a 3-gallon pot. This means it was time to look at the results again, look at the roots, look at the shoots, the leaf size, and evaluate. So what we found between the control and the treatment, there wasn't actually a difference in rooting percentage. Now, this again was an evaluation between a scale of 0 and 5, with 0 being no roots. Obviously, none of those had 0, but 5 being the highest rooting amount and transplant ready. So, no actual statistically significant differences between the two, but let's look at the shoots. So here you can see on the left being the control and the right the treatment. The left is looking a little bit yellow, looks like it's hungry, for lack of better words, but there is difference. There's difference in the leaf size, there's difference in the shoot mass. Now, when we first started this experiment, we did not decide to take shoot weight throughout, so we don't have that data, but with this picture and with many other pictures within these treatment groups at this stage in life, there were differences. Now, we can't necessarily say what those differences may equate to, or what they may mean, but they do look healthier. And we'll follow that healthy word up with an idea of what that means as far as chlorophyll production and growth, but there is better growth. There's bigger leaves, and there's greener plants. Okay, so here we are at week 10 after stick. This is the last week of the project. This is when we want to get all of our data and really see if there is a difference between the control and treatment. It is obvious while taking these photos myself, while looking at the plants, there is definitely a difference between the treatment group, which is the red tag, the plant on the left, in comparison to the conventional plant. Now, there are more leaves, there were more bigger leaves and bigger shoots in general. Now, we didn't actually take measurements of shoot growth, but it is obvious visually. But let's go down further where we do have some hard data and we do have some pictures representing root growth. So rooting at week 10 is really where SAS biostimulants shined. Now, looking at this data first, it's almost a point difference between the control and the treatment. You know, there's no question here, statistically speaking, that there were differences in rooting. So let me just show you pictures, because pictures are worth a million words, not necessarily worth a million data points, but they do say a lot. So here are different combinations, different specific plants at week 10, always on the left being the SAS treatment, the SAS biostimulant, and on the right being the control. Now keep in mind, all of the plants receive the same elemental fertilizer, so the same base, and then the difference being having this biostimulant or not. So differences are obvious. Here's another view, different set of plants. Zoom in a little closer and you can really see the mass of roots. They're all healthy, both sides are healthy. It's just there is a significantly higher amount there on the treatment group. We'll zoom in a little more, and the next thing we can see, and this is very obvious, is the size and the amount of these fine hairs on the roots. There's no question that that is much higher in the treatment group. Now, the last bit of data I'll share is our SPAD meter measurements. Now, this is a really neat non-destructive tool that's used all across plant science that actually will clamp down on the leaf in a non-destructive manner, shine red light and infrared light, and then measure what is absorbed back. Theoretically, chlorophyll strongly absorbs red, so that difference there is called the SPAD measurement. Now, in theory, it represents the amount of chlorophyll, which then represents the amount of nitrogen. So a healthier plant should have a higher SPAD meter measurement. Now let's look at this graph together. So starting on the far left at stick, you imagine these plants have the amount of nutrients and chlorophyll that they would be receiving from the mother stock plant. So it should be healthy. Higher readings, as you can see here in the chart, just about equal readings that the plant gets to finally as it's grown into that 3-gallon pot there at the end. So the plant's cut from the mother, it goes without roots, and so it's using those internal reserves. So it makes sense that in both groups there would be a decrease in green color or in our SPAD reading measurements. So as we decrease, at this point we have been, where my mouse is, at this point we have been planted into our gallon pots, we're receiving fertilizer, and so that decrease should slow. So what you're actually seeing here is that the SAS treatment, the biostimulant treatment, is not dropping quite as fast as the control. And so that's really interesting. It's almost like this biostimulant application is allowing the plant to not use as much as not as much of its internal reserves, or maybe it's just allowing those elements that are there in the pot to be absorbed more easily. That's a theory to be determined. But then, as you can see, as we go back up, as we're transplanted from our 1 gallon to our 3 gallon, that separation comes back together somewhat. I believe we're getting this crossover here at the end, because as you saw in those pictures at week 10 in the 3-gallon pots, those plants are getting quite big. And so plants needing more room for root growth, as well as potentially being at that limit where they do need a higher EC than the 1.8, potentially we're starting to see the beginning of a deficiency in these plants. But we can say with statistical confidence that the biostimulant is being beneficial in not only the chlorophyll retention, but the chlorophyll reproduction and accumulation going further as larger plants. Now, in conclusion, I was very pleased with this product. I'm very glad we took it all the way to 10 weeks, because had we stopped this project at week 4 or 5, we might not have seen the differences. So I think it's important when you're trialing biostimulants, you make sure you give the most adequate time that is proper for your project, as well as being consistent. Like with any organic product you're applying, consistency is key. There certainly were differences rooting. Hindsight is always 20/20 with everything we do, and that includes research projects. We come up with a plan of things we're going to measure according to what we think we will see the most differences in, and how we can support that with statistical significance. Now, if I could go back, I certainly would get shoot weights, but we didn't have that in the original plan. So looking at how this significantly changed rooting, how the plant was able to hold on to its chlorophyll longer or recoup its chlorophyll, and then of course there at the end having this switch in graph due to the biostimulant plants having significantly more rooting and actually going deficient. Those really do show significance in this product, in that it is doing something. Next step with this company, of course, because we see these great results. Well, what does that mean though? Just because something has better roots doesn't necessarily mean the farmer, the grower, is going to have a great ROI from it, meaning they're increasing their yield. So next step, of course, is looking at how this could affect yield. It makes sense that it would increase yield and provide a healthier plant, but we'll see. So this is exciting. I continue to use these products because of those beneficial effects we're seeing. So If you have any questions, I would love to answer them, as well as Nick over at SAS will make sure to load his information where if you do want to contact him, ask for a trial, ask any more questions you may have in detail about these products. But for me, this was a success. This was seeing significant differences, and definitely encourages me to want to take the next step with this product.